Hi everyone, today I want to talk to you about the categorical encodings. I posted a video in my Instagram channel. It got a lot of attention. Many people asked me, can you please explain more about the embedding? Can you explain more about different ways of doing categorical embedding? Today, I want to talk to you about dominant method that you can use for categorical embedding when you're dealing with machine learning or tabular data analysis. Categorical embedding is a major or important part of your analysis, and it's very, very important for you to be actually very familiar on how to deal with this type of encoding. And the reason for that is that most machine learning application, I don't think you can find any data set in real world that doesn't have any categorical variable or categorical features. So one way, of course, is that to ignore the categorical feature, but this is not a good way. There are data sets that has only categorical data. And also categorical features usually are the most important features in a machine learning because they tell you a lot about the type of things that you want to predict. All right. So this is one of the most important videos that you need to definitely watch. So let's start. All right. So first, I'm going to tell you about two different types of categorical variables or categorical features. Number one, not this one. Number one is, let me just name it, types of categorical features. All right. One is nominal. Two is ordinal. Ordinal are the type of categorical features or categorical variables when there is some sort of order, when there is some natural order to them. All right. There is some natural order slash rank to them. What is an example of that? Economic status, for example. Economic status. Like low, medium, and high. A school progress, for example. Different level of school progress. For example, you can have a school level. You can have elementary school, elementary. You can have middle. You can have high school. And they can have college. Elementary school, middle school, high school, and college. All right, so there is some sort of a rank or order. Elementary school is first, middle school is second, then high school, and the next college. All right. Then we have a nominal type of variable. These are the true categorical variable. True categorical variables. And these are the variables that are hard to deal with. They're very challenging. When there is the nominal variables or the variables that there is no order with for them. There is absolutely no order. There is no true order or rank for these variables. Like what? Like what? Like brand of a product. Can have different brands. There is no reason the one is higher than the other one. Like color. It's a very good example, color. Right? So for example, color red, brown, blue. No one said red is higher than brown. There is no order for them. Like city, state, like California, New York, Arizona, right? So there is no ordering between these variables. So it's called nominal. All right, so we have ordinal, we have nominal. We need to find a way to treat or deal with these variables. All right, so great. Now, what are the dominant ways to encode categorical variable? Change the color. I would say popular, not dominant. Popular method to deal with categorical variables. All right. Number one, label encoding. Some people call it integer encoding. Number two, one-hot encoding. Number three, target encoding. Number four, count frequency encoding. They are different, but very similar, very similar in terms of concept encoding. And number five, embedding. All right. In this video, I'm going to tell you about label encoding, one-hot encoding, and if I have time, maybe target encoding. In the next video, I will go into detail on, it depends on this video, maybe target encoding, count and frequency encoding, and embedding in detail. I will tell you the best explanation that you can find in the internet. I have read the explanation in the internet. I didn't like them. I'm not saying that the explanation are not good. What I'm trying to say is that they are minimal. It leaves you ask this question that, okay, I kind of understand what they mean, but not really. I'm not sure. So I try to actually solve that ambiguity. All right, let's start. Label encoding. What is a label encoding? You want to be very practical and at the same time very efficient. Label encoding is a type of encoding, or integer encoding, is that you replaces the category or label with the integer. It's just an integer number. Replace the categorical features with integer numbers. Example. Let's say city. I have city here. I have Los Angeles. I have San Diego. I have Irvine. Right? In categorical embedding, sorry, not categorical, in the label encoding, that's what's going to happen. You're going to assign Los Angeles to be 0, San Diego to be 1, Irvine to be 2. You assign an integer to them. All right. So for a male and male, 0, 1, female and male, 0, 1. I don't know. Color, for example, another one, color. You say red is equal to 0, brown is equal to 1, blue is equal to 2, yellow is equal to 3, right? That's the type of label encoding. All right, so let's talk about this. Is it good or bad? Guys, categorical embedding can be used for ordinal variables. So not categorical embedding, sorry, label encoding. Keep using this. Label encoding is a great option. It's a great option for ordinal categorical features. Only and ordinal. It doesn't make any sense to do it for nominal. It does not make any sense to do it for nominal categories. Very important. What was ordinal? When there is a natural order or rank. All right, so come here. If you have a low, medium, and high. I would say low is equal to 0, medium is equal to 1, high is equal to 2. That makes sense. Why? Because when you put an integer, you bring a notion of distance. You're saying that 2 is greater than 1, and 1 is greater than 0. And that kind of makes sense. High is greater than medium, and medium is greater than low. So there is a rank, there is an order associated with them. But who says yellow should be greater than blue? So when you get feeding it to machine learning models, the machine learning model says, wait a minute, 3 is greater than 2. All right. So to me, yellow is greater than blue, and blue is greater than brown. But that's not correct. These colors have no relationship with each other. Who says that one should be higher than the other one? And the same thing is for the cities. The same thing is for the cities. All right. Very, very, very important. All right. So cons and pros. Cons and the pros and cons of the pros. Pros first is that easy to implement. Another one. Very, very important. It will not increase the dimensionality of the feature space, the dimensionality of the feature space. Super important, super, super important. When we go to one-hot encoding, you will see why. Can be used for ordinal categories. All right. Choose a different color. Pros. And the cons, it cannot be used for nominal categories or when there is no order, when there is no notion of order or rank. Another cons is that it introduces the idea of distance and treats the category or variable as pure integer, which is very similar to the first one. So it cannot be used with nominal. So it's saying that 4 is greater than 3. 3 is greater than 2. That's not correct. Red is not greater than brown. Brown is not greater than yellow. By any means, this is not correct, right? So it's very limited in a sense. Label encoding is very limited. It can only be used for ordinal variables. All right. Hope this was actually clear. Now we go for one-hot encoding, one of the most popular one, one-hot encoding. But what's one-hot encoding? You see, one-hot encoding is a type of encoding where you replace a category with the vector of zeros, bunch of zeros, and a 1. And a 1 is only at the location where this category appears in the data. All right, I will explain about that in the column. All right. So in the one-hot encoding, in a sense, it's used, first of all, what it's used? It's used for nominal categories. It's really good because that's what we are trying to answer for nominal categories. And what it does is that replaces the category with each category with a vector of zeros, all zeros and 1. All zeros and 1. Let's see. It would be better if you do for clarity, I write it like this: all zeros and a one. All right, so let's see what it does. Let's take a color as an example. We have red, we have blue, and we have orange. All right. So if you get a machine learning model, for example, you get something like this. Here is the color is one of the feature. You have red, you have blue, and you have orange. All right. So in the label encoding, we just saw that if you do the label encoding, you get 0, 1, 2. And we said it's really bad because there is no order. What one-hot encoding does is as follows. It creates 3 different columns, as many as the number of categories. We call it red, blue, and orange. Right. So what's going to be red? Red is going to be 0. No, sorry. Red is going to be what? 1, 0, 0. All 0 vector besides the 1 at the position that this appears. So red is the position number 1 here, number 0 here, if you use Python, number 0. So you have a 1 at that position. Blue is the middle position. We have 0, 1, 0. And orange is going to be 0, 0, 1. You see what's going to happen? How many columns do we have? How many columns? As many as number of categories. You're starting to see the problem here. All right. And what sort of new columns we have? Very sparse with all zeros besides 1 only at a given location, So what does one-hot encoding do? It replaces the categorical variable with a very sparse vector. How many vectors? As many as number of categories. Wow. What does it mean? Guys, I have, let's say, countries. Country, let's say. I have a country in my data set. What's the cardinality of a country? Let's say the number of category is 100, let's say, in my data set. If you use label encoding, you have only one column encoded from 0 to 99. If you use one-hot encoding, you have how many? You have 100 columns of sparse vector of all zeros and 1. All right. So if you want to see an example of that, this is the country column. So here you have US, UK, India, and then in the label encoding, you have 0, 1, all the way, let's say, to 99. In the one-hot encoding, You see the problem? In a one-hot encoding, you get US, you get UK, all the way to India. So you get 1 all the way to 0. You get 0, 1 all the way 0, and then you get 0, 0 all the way 1. Okay? So now what is the pros and cons? Pros, it can be used for nominal features with low cardinality. Another one is that the features are the encoded features are independent, right? Or uncorrelated. So if you, how do you see that, the dot product? If you see the dot product of US vector and then UK, so it's like 0, sorry, 1, 0, all the way 0, 0, 1, all the way 0, and the dot product is 0. So in a sense, they are independent. There is no notion of a distance. It does not introduce the notion of one feature is higher than the other one, higher than the other one. The notion of one feature higher than a rank or order, in a sense. All right, great. This is all good. That's why it's, I will write pros here. Now cons. Wow, cons. It cannot be used for categorical features with high cardinality. Okay. I would say that any feature more than 10 categories should not incorporate one-hot encoding. Another one is that it introduces unnecessary sparsity to a problem. All right, that's the concept that one-hot encoding. They're all very easy to implement in Python. Label encoding, one-hot encoding. Actually, one-hot encoding is really tricky. There are two ways. pt.get dummies using pandas and one is using scikit-learn. I will create a video and tell you that which one you should use. There is a caveat to use the pandas one. A lot of you will use the pandas. There is a problem for using that one. But that's it for this video. I talk about label encoding because it's getting very long. Label encoding and the one-hot encoding. In the next video, I'm going to talk about the target encoding, count and frequency encoding, and then maybe next video I will talk about the embedding. Depends on how long the video takes. That's it for this video. If you like this video, please like and subscribe to the channel, share it with your friends, and I see you all in the next video. Thank you so much.